Good morning everyone, and thank you for attending to this presentation. We are Martín, Julio, García, Natale from the Universidad Autónoma de Madrid and Samuel Castillo Jiménez from the Universidad de Alcalá. And we are going to present the main results of our research about breakage patterns on upper Solutrean winged and stem points and the incidence of weight to thickness ratio. First, we will talk about the research context, which is focused on the techno-economic behaviors of Solutrean and, particularly, of upper Solutrean hunter-gatherers. Secondly, the main problem that guided our interest research was difficulties in our understanding of breakage patterns of upper Solutrean winged and stem points from the Mediterranean region. According to this, we propose a main hypothesis to work with and some main objectives in order to try to create a database of experimental diagnostic impact fractures. Finally, we will talk about the development of the experiment and the main achieved results. We also would like to point out that this research is still in progress and that here we are just introducing some preliminary results and some future projects that we are now working on based on this first experience that we are showing you all. Winged and stem points are one of the most recognized type of hunting weapon from the upper Solutrean record of the Mediterranean area in the Iberian Peninsula. Nevertheless, there is also some presence of these points on the Atlantic side, on the Algarve and the Portuguese Extremadura. In our case, we decided to focus our research on the lithic assemblages of the Ambrosio Cave, located on Vélez Blanco, Almería, and the Parpalló Cave, located in García, Valencia. We chose these two sites because of the difference of tipometric values between the winged and stem points from both caves and the possibility to establish a difference between two subtypes of the same kind of point. Moreover, poor research has been done around this type of points and the breakage patterns produced during the Cinegetic activities. We wanted to test if tipometric values could affect on different types of breakage patterns, so we first assumed, as a main hypothesis, that weight to thickness ratio was able to produce different breakage patterns. Being able to prove this was our main objective, but we also wanted to establish a breakage patterns dataset focused on winged and stem Solutrean points from the Mediterranean Iberian Peninsula. The methodology we developed was the following. Firstly, we made a technological analysis of both subtypes of winged and stem points from the Parpalló and the Ambrosio Cave. We established two optimal groups where the Parpalló points show a lower weight to thickness ratio, while the Ambrosio ones show higher values. Secondly, we decided to make experimental replicas of both subtypes of points. Thirdly, we recreate the hunting activities under an experimental protocol in order to use the replicated points. Fourthly, we analyze the fractures of the used points in order to, finally, get some preliminary conclusions and prove or refute our main hypothesis. Concerning the experiment, we decided to use very good quality and homogeneous flint for making the experimental points. The selected flint was certainly used by the upper Solutrean hunter-gatherers, and its quality is excellent for identifying impact fractures. The process of making and preparing the points was the following. First, we made the points using the same techniques as recorded on the Iberian Solutrean sites. All of them were made from flakes produced with hard hammer direct percussion, then reduced with soft hammerstone, and finally pressure flaked into the desired shape. Secondly, the points were carefully measured. Thirdly, we decided to recreate an arrow shaft using river cane. All the points were attached into individual foreshafts made from the same cedar wood and measuring the same, so we could shoot all the points using the same arrow shaft. Here you can see some of the produced points. Totally, we made 44 points. We decided to submit all the measurements of the weight to thickness ratio into a blind test in order to get two clear different series of points. We finally got 26 points, 13 of each group, that were clearly different on its width to thickness ratio, as you can see on this plot showing the normal distribution of the measurements of each group. Regarding the ballistic gel, we made it following the official guideline established by the United States of America FBI on ballistic test and forensic experiments. We used 100% swine gelatin and we disposed cow ribs in order to recreate an animal ribcage. The shooting of all the points were done in 2 sessions due to weather conditions and time issues. Nevertheless, the process followed was all the same. All the arrows were shot by one of us with the same bow, a 40 pounds Robinia pseudoacacia flatbow, at a distance of 10 meters. The draw of the bow was also intended to be the same, thanks to the marks we settled on the arrow shaft. We decided to use a bow because of the precision and control that it allows us in front of other propulsion systems, like the spear throwers. Concerning the main results, here you can see a simplified view of the type of diagnostic impact fractures. This group of points belongs to the first series of points, with a lower width to thickness ratio. You can see that we have a full depiction of all the typical impact fractures, like the burinated fractures, flute-like fractures, and crash tips. Bending fractures were also present on the mesial and distal sides of some points, not only on the stems as shown in this image. Concerning the second group, with a higher width to thickness ratio, we have also the presence of all the same kind of impact fractures, as you can see in this image. Nevertheless, when grouping and comparing the frequency of the different type of diagnostic impact fractures, we can clearly see that, on the one hand, the points with a higher width to thickness ratio have a more homogeneous depiction of breakage patterns. On the other hand, there is a clear overrepresentation of flute-like fractures on the points with a lower width to thickness ratio. This is probably because of the higher stress produced on points that tends to be thicker. We also took a look into other tipometric values, such as the length of the fractures produced. It seems that there is a different shift between both groups, as you can see on the plots. However, we must take into consideration that both groups were established following a width to thickness ratio criteria. So, we can have an overrepresentation of bigger points that, when fractured, produce longer fractures. Moreover, these results encourage us to work on the control of other tipometric values, like the morphometry of the points, in order to check the reason of this potential shift. Finally, we can establish some preliminary conclusions from the experiment we developed. Firstly, it seems that there is little correlation between width to thickness ratio and breakage patterns. We have seen that there is an overrepresentation of flute-like fractures on points with a lower width to thickness ratio. We assume that it can be produced by the higher stress produced on points that are thicker. Secondly, the presence of bending fractures on both groups should be taken into consideration also as a product of impact fractures resulting from hunting activities, and not only napping related. Thirdly, we think that we need a larger experimental sample, especially in order to understand the breakage patterns of the wings and the stems of these types of points. Fourthly, we should take into consideration other tipometric values such as the morphometry of the points, and also we should try to adjust a more controlled experiment regarding, for example, the surface of impact. Fifthly, we consider that microscopical analysis is needed, especially for understanding the fractures from the wings and the stems that are much more discrete. but also to identify clearly typical fractures on crash tips. We would like to thank you all for your attention and hope you have a great day. See you on the discussion session.